YouTube, Edgar here, and welcome to Artifexian. Here you will learn everything you ever wanted to know about world building, and then some. The last video was all about giving your hot Jupiters, hot Neptunes, and hot Saturns stable orbits. In this video, let's discuss classical gas giants, super Jupiters, gas dwarfs, and eccentric Jupiters. Same method plus a few modifications. 1. Semi-major axis. So the frost line is a particular distance from a star where it is cold enough for the building blocks of gas giants, volatile compounds, to exist in solid form. Expect to find classical gas giants like Jupiter here, 1 to 1.2 AU away from the frost line and beyond. Remember, the location of the frost line is given by 4.85 times the square root of L, where L is the luminosity of your star relative to our sun. Super Jupiters, more massive versions of Jupiter, can be found in this zone, i.e. between 0.04 AU and the frost line plus 1 to 1.2 AU. Although the frost line will likely be where your system's most massive gas giant will form, migration may occur, and a super Jupiter formed there could wander inwards. WASP 17b is an example of a super Jupiter that likely formed at the frost line and then migrated inwards. It's 10 times the mass of Jupiter and orbits at 0.02 AU. Place gas dwarfs, gaseous planets up to 10 Earth masses here, between 1 to 1.2 AU from the frost line and the outer limits of your planetary system, which by the way is given by 40 times m, where m is the mass of your star in solar masses. For extra added realism, try and stick to a very distant orbit for your gas dwarfs. Finally, for all intensive purposes, eccentric Jupiters are total renegades and can orbit pretty much anywhere in a system. Speaking of eccentric, 2. Orbital eccentricity. Classical gas giants, gas dwarfs, and super Jupiters will tend to be on very circular orbits, so our eccentricity range of 0.00x to 0.0x from the previous video still holds. Eccentric Jupiters, however, will have orbital eccentricities of 0.1 or greater. Remember, if you want your system to have a habitable Earth-like planet and an eccentric Jupiter, keep the eccentricity of your eccentric Jupiter between 0.1 and 0.2. This reduces the gravitationally devastating effect an eccentric Jupiter can have on a system. This is a friendly eccentric Jupiter, so to speak, and this, a not so friendly one. Check out the difference. 3. Semi-minor axis, periapsis, apoapsis, and orbital period. No special consideration needs to be taken when calculating the semi-minor axis, periapsis, apoapsis, and orbital period of your classical gas giants, super Jupiters, gas dwarfs, and eccentric Jupiters. This is because all of these orbital elements rely on the semi-major axis and eccentricity, which we've already discussed. But just to recap, the equations from the last video were: the semi-minor axis is given by b is equal to a times the square root of 1 minus e squared. Periapsis is given by a multiplied by 1 minus e, apoapsis is given by a multiplied by 1 plus e, and orbital period is given by p is equal to the square root of a cubed divided by m. In all cases, a is a semi-major axis in AU, e is the eccentricity, and m is the mass of your planet's star in solar masses. 4. Inclination. For classical gas giants, super Jupiters, gas dwarfs, and eccentric Jupiters, ensure that they orbit in a prograde fashion, i.e. in the same direction as their parent star. For all 4 types of giant planet, choose an orbital inclination between 0 and 90 degrees. A warning though, don't go wild. Save the really highly inclined orbits for your Kuiper belt objects. I mean, look at the gas giants in our system. Their orbital inclinations lie between 0.77 and 2.48 degrees. 5. Longitude of the ascending node and argument of periapsis. Longitude of the ascending node values range from 0 to 360 degrees and determine the orientation of your orbit in 3D space about the y-axis. Argument of periapsis values again range from 0 to 360 degrees and determine the orbit's orientation about the z-axis. Feel free to choose values at will for both the longitude of the ascending node and the argument of periapsis. Got it? Cool. To give you a sense of scale, here's a system featuring all the types of gas giants discussed in this video and the previous video. Namely, a hot Jupiter, a super Jupiter, a classical gas giant, an eccentric Jupiter, and a gas dwarf. Stats on this system and its planets in the doobly-doo, if you're interested. Happy building, everyone. Good morning, Interweb. Welcome to the new end card. I really hope you enjoyed this video on how to put other gas giants into orbit. If you're interested in more Artifexian content, click the links below me for more videos. And if you think my one-man mission to build an entire fictional universe from scratch deserves it, hit the subscribe button. Thank you all so much for watching. Edgar out.